This slide shows 3 soil profiles with arrows indicating movement within the soil. Why is it important? Because climate is basically that soil forming factor that determines the dominant direction of water movement in the soil. The most important idea that soil is not static. Materials are constantly moving through the soil profile, mainly driven by the water. The vertical arrows, the blue vertical arrows, represent movement in the water. On the left side, you can see a longer arrow. The arrow that points downward, it's longer than the arrow that points upward, which represents dominant downward moving water, which is the dominant process in humid tropical environments. So this means that in humid climates, where the amount of water moving downward in the soil exceeds the amount of water traveling from the bottom to the top, it dominates. Water moves through the soil from the top to the bottom. It dissolves and transports dissolves materials like different kinds of salts, and transports materials such as clay and organic matter, for example, sometimes. As these materials move downward, some are removed from the upper horizons, from here, and others accumulate in the subsoil. This creates differentiation between horizons. For example, a lighter upper horizon and a more clay-rich or iron-rich subsoil. So in tropical climates, there is a huge amount of rainfall, but very limited evaporation. The dominant direction of the water movement in the soil points from the top to the bottom. In some other cases, mostly in arid or semi-arid environments, we can have upward movement of the water, but in humid environments, this is usually less important than the downward movement. That is why we do not discuss this in detail. These processes dominate mostly in salt-affected soils. And we have soils in which the amount of water moving down, the amount of that water is approximately the same to the amount of water that travels upward. This water regime is mostly characteristic to the continental climates. Still climate. This slide shows climate patterns across Africa, but our focus is on Liberia. If you look at West Africa, Liberia falls clearly within the humid tropical or equatorial climate zones. This means we have high rainfall throughout much of the year and consistently high temperatures. These two factors together are extremely important because they control almost all soil forming processes in the country. High rainfall leads to strong leaching, meaning that water continuously moves downward through the soil and removes soluble elements like calcium, magnesium, silica. At the same time, high temperatures accelerate chemical reactions, so minerals break down very quickly. The result is that the soils in Liberia are typically very deeply weathered, often with red or yellow colors due to iron and aluminum oxides, and the soils in Liberia have generally low natural fertility. Another important point is the biological activity is very high under these conditions. Organic matter is produced and decomposes rapidly, so surface organic matter-rich layers are usually thin. In low-lying areas where water can accumulate, we often you also often see so-called hydromorphic conditions, meaning soils may be periodically saturated with water. This slide shows three important climatic variables across Africa: precipitation, temperature, and the length of the growing period. Of course, instead of trying to read the whole continent, we focus on Liberia. Liberia lies in the humid tropical zone. This means that the rainfall is high, temperatures are constantly high, and the growing period is long, often nearly continuous. These three conditions together are extremely important for soil formation. High rainfall drives strong leaching, in which water moves downward through the soil and removes soluble elements like calcium, magnesium, and silica. High temperature accelerates chemical reactions, so minerals break down very quickly. At the same time, the long growing period means that biological activity is continuous. Organic material is produced and decomposed rapidly, so we do not usually see thick organic layers in soils.